Okay, welcome back everybody. Okay, we're looking at lesson 6, continuing on with stretches. Okay, so again, stretches occur when in the equation you replace x with, say, 5x or replace y with 3x. So you'll see the coefficient in front of the variable as opposed to like translations where it's added or subtracted. Okay, let's try example number 1 here. Write the equation of the image of y equals x squared after a horizontal stretch about the y-axis by a factor of 3/4. Okay, so we're using specific functions now rather than just y equals f of x. That's how this lesson is slightly different than what we were working on. Okay, so let's first set up the replacement. So horizontal, we're talking x, right? X would be replaced with, our stretch factor is 3/4. So if our stretch factor is 3/4, we flip that to get 4/3 x. So we would replace x with 4/3 x in the equation, okay? So that would make our new equation, scoop the x out, okay? Put the new x in, 4/3 x. Okay, and that really could be your answer. If they had gone further, they might have squared the 4 and the 3 and the x, and they could have gotten an answer like this. Square the 4, 16, square the 3, 9, square the x, x squared. Okay, which is kind of interesting because that would then be the same as a vertical stretch because now it's in front of the whole function. Vertical stretch by a factor of 16/9. Okay, it's not with the y, so therefore you don't flip the factor. Okay, interesting side note. B, y equals square root of x minus 3 after horizontal stretch by a factor of 4 about the y-axis and vertical stretch by a factor of 2 about the x-axis. Wasn't that fast? Okay, so let's do our replacements. Horizontal stretch, x gets replaced with stretch factor of 4, flip it, 1/4 x. Okay, and vertical stretch, so y gets replaced with factor of 2, 1/2 y. All right, so let's take our function, y equals square root of x minus 3. Scoop the y out, put in our new y, which is 1/2 y. Scoop the x out and put in our new x, which is 1/4 x. And then we still have the minus 3. And there we go. We could leave it like that, or we could isolate the y and multiply. How would we isolate the y? We could either divide by a half, or easier would be to multiply by 2. And that would get rid of that. Hang on one second. Okay, so we multiply both sides by 2. That would get rid of the 1/2, and we would just have y equals. Now, multiplying the right-hand side by 2, you don't go inside the root, okay? That's part of the function. Don't touch that. Okay, so we'd have 2 bracket 1/4 x, and then the 2 would also get multiplied by the 3 because that's a separate term. And that's another version of the equation we could have. All right, let's look at part C. Y equals 3x plus 7 after a vertical stretch about the x-axis by a factor of 1/3 and a reflection in the x-axis. So we're combining some transformations here. First, vertical stretch. Okay, y gets replaced with stretching, we multiply, and it'd be flip the factor to get 3y. Reflection in the x-axis. Okay, let's kind of picture that in our head. If we reflect in the x-axis, the point would go down here, which means y would change sign. So that means let's throw a little negative in front of that negative 3y because we're changing the y. All right, so in our equation, y equals 3x plus 7. Scoop the y out. Put in our replacement, negative 3y. Okay, and again, we could isolate y. So how are we going to do that? We are going to, this time, divide both sides by negative 3. And notice on the right side, I'm dividing each term. That'll aid in simplifying in a second here. So y, because now negative 3 is gone there, okay, equals 3 divided by negative 3 is negative 1, or negative 1x. And then positive 7 divided by negative 3 would be negative 7/3. And there we go. That could be our answer. All right, let's look at the next page. Okay, example 2. Describe how the graph of the second function compares to the graph of the first function. Okay, so it's like, Sesame Street. What looks different? Okay, looking at part A, we started with y equals f of x. We then had y equals f at 1/2 x. So, Sesame Street time, what was done? X was replaced with 1/2 x. So, notice something being multiplied by x, that means it's a stretch. It's x, so horizontal stretch. Okay, and it'd be by a factor of, okay, it's with the x, so you flip it to get a factor of 2. Okay, let's look at B. Actually, you know what? Why don't you guys try B and then we'll check back in and then we'll do C together. Okay, so pause your videos and hopefully we all ended up with horizontal stretch by a factor of 1/3. That's how the second graph compares to the first graph. X is replaced with 3x, take the number and flip it over to get our stretch factor. Okay, let's look at C. C, we started with y equals absolute value of x. We ended with y equals -2 absolute value of x. Notice x, that part didn't change at all. So we have no horizontal stuff happening, okay? However, we do have a 2, which means we're going to have a stretch. And the only other stretch kind would be vertical stretch for us. So we're going to write that down right away, vertical stretch. And we have a negative. Recall what a negative means. That's a reflection. Okay, so let's first write those down. Okay, vertical stretch. This too is not over here with the y, is it? So that means we do not flip it to get our stretch factor. So vertical stretch by a factor of 2. Okay, the negative in front of not the x, so it's essentially in front of the y. Let's think about that. If a y value goes negative, we are reflecting over the x-axis. And there we go. Okay, why don't you guys try part D? And you know what? Try D, E, and F. All three of those. Pause your video and we'll check back and see if we have the same answer. Okay, so on D, our answer should be vertical stretch by a factor of 1/3. The 3 is with the y, so therefore you reciprocal it to get the stretch factor. Okay, E, we should have answers of vertical stretch by a factor of 2. You do not reciprocal that because it's not with the y, but it is a vertical because it's not inside with the x. Horizontal stretch factor by a factor of 3. And we flip that because that's with the x. Okay, F, horizontal stretch by a factor of 1/2. There's a 2 in front of the x, therefore we reciprocal to get the stretch factor. Horizontal because it's with the x, and negative inside with the x causes x to change sign, which means we would be reflecting over the y-axis. Okay. Example number 3, we're going to look at compare two graphs and then figure out what's been done and how to get the new equation for the new graph. So we're going from the thin line to the thick line. Okay, we did something similar to this in reflections and translations. So let's look at A. Okay, so here's our thin line, here's our thick line. So looking at that, it seems to me it's been vertically stretched. Now, a good place to tell how much it's been vertically stretched would be with a y-coordinate we actually know. So I know on the original graph that this y-coordinate appears to be 6 on the y-intercept. The new y-intercept appears to be 3. So how did we get from 6 to 3? I'm thinking vertical stretch by a factor of 1/2. We multiplied 6 by 1/2 to get 3. So the replacement for that would be y would be replaced with, flip that factor, 2y. Okay, so in our equation, here's our equation here, we're going to scoop y out and put in 2y. And we could leave it like that, but let's isolate y. So a little tricky here, we're going to divide both sides by 2. Okay, divide by 2, and I'm going to write it like this, divide by 2. Okay, that'll isolate y. On the right-hand side, let's write it like this. You ever heard dividing by a number same as multiplying by the reciprocal? So dividing by 2 would be the same as multiplying by 1/2. And by doing that, 2 can then divide into 6 3 times. So our final answer would be 3 over x squared plus 1. And there we go. Okay, B looks a little tricky. Looks crazy, actually. Okay. It's completely upside down, isn't it? So there's been a reflection for sure. But let's talk about stretches first. Okay, so let's see if there's any stretches. If you're testing to see if there's any stretches, you need to find some known quantity here. Horizontally, this length here, 1, 2, 3, is still 1, 2, 3 length on the new graph. So it hasn't been horizontally stretched. So I'm going with vertical stretch. So let's write vertical stretch. Now let's measure this overall height of this original graph. So 1, 2, 3, 4, 5 went from a height of 5 to, what is this height? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it went from 5 to 10. Okay, so to go from the number 5 to the number 10, we would have to multiply by 2. So vertical stretch by a factor of 2. That means y would be replaced with 1/2 y. Okay, now there's definitely a reflection going on here because it seems to be not only upside down, it actually seems to be backwards, doesn't it? So that means we have a reflection, 2 reflections in the x and y axes. Okay, because this piece here used to be over here, so it got flipped over the y-axis, and this part used to be on the bottom, and now it's on the top, so over the x-axis as well. So that means our replacements, the reflection in the x-axis would put a negative on this 1/2 y, and x would be replaced with negative x. Okay, where's our equation? Here it is, y equals f of x. Replace y with negative 1/2 y. Replace x with negative x. Okay, then we're going to isolate y by multiplying. How do we get rid of that fraction? Multiply by the reciprocal, including the negative. Okay, and again, note multiply inside that f. We keep it on the outside. Negative 2 f at negative x. There we go. That's our answer. Okay, C. Let's take a look at C. How about you guys try C on your own? See if we get the same answer. Okay, so the thing you want to pick up on this one to figure it out is what the x-intercepts did. That's a good place to kind of look at, see what was done to the graph. You notice the y-intercept didn't change from one graph to the next. So that means nothing happened to it vertically. Horizontally, we had an x-intercept of 2 went to 4, 6 went to 12, negative 4 went to negative 8. That implies that we multiplied the x-coordinates by 2, which means horizontal stretch by a factor of 2. In the equation, that would require us to replace x with 1/2 x. Okay, so if we do that with the equation, this would be what we get. And this answer here, perfectly okay, but it's possible maybe a different form was presented on a multiple choice test or something like that. And this is how they could get it. They could factor 1/2 out of each of these terms. So 1/2 factored out of the first factor would leave x minus 8. Negative 4 divided by 1/2 is negative 8. Okay, same thing for the other two factors, and then finally multiply 1/2 by 1/2 by 1/2 to get 1/8, and there we go. Now something I want you to notice, if you take a look, if each one of these factors was set to 0, you get your x-intercepts. Each one of these factors set to 0, we get the x-intercepts on the new graph. Cool, eh? Okay, let's look at the last example on the next page, hopefully finish up in this video. Okay, so polynomial function has this equation. All right, now remember what we talked about with the x-intercepts? We can find those again here, which we're going to do. Oh, x-intercept 0, same thing, right? And the y-intercept if the following transformations are applied. If they want the new zeros in y-intercept, we're going to have to figure out the old ones first. Okay, and I'm just looking at the clock. I think what we'll do is we'll finish up this example in part 2 of the video, and I will see you in part 2. Well, maybe not see you. You can hear me in part 2. Okay.